that's fine, but the keyword is quiet. Feel free to get some free answers and hopefully you understand how to get there because tomorrow the questions will be the same style, just different numbers. So yeah, you could copy from your friends and get all the answers to the study guide, but doesn't really do you much help if you don't know how to get there for tomorrow. So number 4 was the one that's requested. It says the height in feet of a ball thrown in the air is modeled by this function. It gives you an equation. And it says where t represents the time in seconds. So complete the table by filling in the height in feet of the ball for the given values of t. So t is in the position of where the x would normally be. So t is your input. It also stands for time, which is normally your x anyway. So all I really have to do for these, because it gives me values for t, is in my given equation, anywhere that there's a t, replace with whatever number is in the table. And then whatever number you get from putting it in the calculator will be the height. And that's all you type in. So this one is actually pretty easy. You can probably do this one in your head. So this one's just going to be 24. So that means at 0 time, what was the starting height? Remember, I told you the constant would always be your starting height. But feel free, all of it can go in the calculator. So like put the whole right side of the equal sign in the calculator and you'll get an answer. That is 24. Then just change the t each time. So now we're plugging in 1. And let the calculator do the work for you is what I would suggest. So this one would be 24 plus 50 parentheses 1. Anytime you plug something in, always use parentheses. Minus 16 parentheses 1. Squared is, well, here's a square. But otherwise it's like shift 6 on your keyboard. And it's that little like upward arrow. That's what it looks like before you press enter. And we get 66 for that first one. And then keep doing the same thing, replace the t, whatever h you get is what goes in the table. So that should be 5 easy points on the test tomorrow. Questions on that? Any particular other ones you need to see on that one? Yes. Okay, number 2. So any questions on this one before we move on? Okay. So number 2, same, this one, right? Okay. So that may or may, I'll have to check the key. So let's do it real now and we'll see if there's actually supposed to be answers. But yeah, it does select 2, so you would think that there's 2. So let's see for this particular question how many answers there are. So the graph of the quadratic parent equation is this. So remember, that's like the most simple one that we can come up with. That's the minimum requirement for it to be a quadratic. Select 2 equations that represent a shift of the graph of the parent equation to the left on the coordinate plane. And that's all it says. It doesn't say down, doesn't say stretch, compress, nothing like that. So do you guys remember what that would do to your equation if there's movement to the left? The most helpful lessons would be like the vertex form. So like what we did Thursday. For that one, here's what vertex form is. I'm debating on whether or not to give you this equation on the test. If I did, it would literally just be this. I would not tell you that the vertex is HK. I would not tell you what A, H, and K do, but I would give you what vertex form is. So with that, any changes to the A, it's either going to be stretched, compressed, or reflected, depending on what that change is from the parent graph. And the parent graph, the A is 1. For the H, that's any left or right movement. And then any changes to the K would be up or down movement. All right, and in the parent graph, H and K are both 0. So if there's a value in parentheses with the X, then that means it's left or right movement. So looking at that, I know like my answer cannot be this one. I don't know if it's shuffled on yours. I don't think so. But it can't be this one because there's nothing even in parentheses with the X. So don't pick that one. It cannot be this one either because there's no H, right? There's a K because it's outside of the X squared. But if it's an H, it's in parentheses with the X. So between these two, the sign will tell you if it's left or right movement. Do you guys remember which is which? If it has a plus in the equation, then that means it moves left. 2 units for this one. If it's a negative in the equation, like it looks negative, then that means it moved right. And this one moved right 3 units. So in this one, there's only one answer. I'm just going to change the wording for this so that it just says one answer. But on your test, there's probably more because they just, whoever made this, copy and pasted the test into here and then change the numbers. So questions on that? All right, the way that I always think of it, since it's supposed to be negative in the equation, I think like if it looks right, meaning the H is negative there, then it moves to the right, is how I think of it. If it's plus, then it moves left. Questions? All right, I'll make a note to myself to fix it, so it just says one answer. Any other questions on either the constructed response or the 100-point portion? We have like 5 minutes left, so we can go over a couple. On the puzzle piece? Okay. All right, so number 3, more transformations of the vertex form. So I told you vertex form would come up like at least 3 times on your test. So select all the statements that could describe the transformation of the following quadratic. So let's see. Vertex form was this. Let me copy it over again. So this, I'm making the decision now. I will provide you this part. I won't tell you anything else tomorrow on the test. But any changes to the A would be either stretched, compressed, and or reflected. Let's start with the easier one. Do you know how to tell if it's reflected or not? If it's negative, it's reflected. So is this one going to be reflected? So then take the one that says the quadratic is reflected. All right, so if A is negative, then there's a reflection. Now, the value for A, like whether it's 2, 3, 0.5, whatever, will be stretched or compressed. So ignore the negative. Don't even worry about the negative because that's just a reflection. If it's a 2, would that be stretched or compressed? Okay, Julian says stretched. Anyone disagree with him? All right, so yeah, it is stretched. Because if the absolute value of A is greater than 1, so that means it doesn't matter if it's negative. But the absolute value of -2 is what, class? 2. So if that's greater than 1, then it's a stretch. If it's smaller than 1, like, for example, 0.5, 0.75, 1/3, something like that, then that would be compressed. So this one has an absolute value of greater than 1 and stretched. So that's the A. We still have stuff going on for the H and the K, because otherwise that wouldn't be there at all. It would just be X. So if it's a +3 with the X in the parentheses, what type of movement is that? Good. So it goes left 3 which is this one. So H, remember, is left or right. Since it says +3, it moves left. And then there is movement up or down, that's the K. If K is positive, is that up or down? Up. K, I think is easy. If it's plus K, you go up. If it's negative K, you go down. Do you know how you can check just to be sure? Tomorrow? You could play around with Desmos. So remember, your parent graph is always x squared. All right, you could graph x squared, and then you could graph the one in vertex form, exactly how it looked on your paper. And what was it, +4? And you could count, I think the best way to compare is between the vertex. Okay, so we went left 3, which is what we said. We went up 4, which is also what we said. The stretched or compression is a little bit harder to see, but this one is more narrow. So that's a stretch. And then it is reflected too, because it's flipped. So you can verify that all with Desmos. I wouldn't use Desmos as a starting place, but however you get to the right answer is fine with me. So questions, comments, concerns? All right, test is tomorrow. Feel free to email me your questions if you think of one later. Feel free to resubmit your binder